4.3b, we're going to evaluate whether a statistical study has been carried out in an ethical manner. Here we're going to look at animal testing and the lack of realism. When new products are being developed for use by humans, they're often tested on animals first. While animals share some physiological features with humans, they are not the same. Therefore, we should always be cautious of applying the results of tests on animals to humans. So, is it realistic to make the same connection? Be cautious. Another type of thing with ethics, do tanning beds cause skin cancer? Doctors have noticed that people who frequently visit tanning salons are much greater risk for skin cancer. But are the tanning beds the cause? Could the association be due to a lurking variable such as other sun exposure? After all, people who like tanning indoors probably like to tan outdoors. An experiment would help to settle this question, but forcing people to use a tanning bed to see if they get skin cancer is incredibly unethical, and it's just not something that we do. This is where you would choose to do an observational study because of the ethics behind doing an experiment are just not good. Now, what if you're doing something and if you did an experiment, it would be considered unethical? Therefore, you need to keep it as a study. Well, there are 5 criteria for establishing causation when we can't actually do an experiment. The first step is you want to see if the association is strong. If it is, for example, the association between smoking and lung cancer is very strong. So because this association is strong, you hear information in the news about this type of causation, about smoking and lung cancer, even though technically an experiment was not conducted. The second thing, is the association consistent? And that just means that most of the studies of different kinds of people in many countries link smoking to lung cancer. Just not a study done in the US or a study done in the UK. Most of the studies they do. That then reduces the chance that a lurking variable specific to one group or the study explains the association. So if enough people in different countries where people are different see the same connection, we see some consistency, so causation could possibly be warranted. Third thing, larger values of the explanatory variable are associated with stronger responses. So larger values in our smoking example would mean that people who smoke more cigarettes per day or who smoke over a longer period. So if we see there's a strong association for the quantity going up or the period being extended on smoking and actually getting the lung cancer more often, in this case, people who stop smoking would then reduce their risk. So because they're smoking more and for a longer period of time, we do see more lung cancer happening. Again, maybe causation could be applied. Number 4, if the alleged cause precedes the effect in time. And what that means is that lung cancer develops after years of smoking. The number of men dying of lung cancer rose as cancer became more common with a lag of about 30 years. So what they're saying here, because of the lag in time, we can still make the causation that we could tell that it was implied with smoking. And then the last thing is the alleged cause. Is it plausible that there's an association? And with that, experiments with animals actually show that tar from cigarette smoke does cause cancer. So yes, we're seeing it in animals and it causes cancer. Therefore, is it plausible that it could happen in humans? So let's wrap up the chapter by looking back at the magnets and the pain case that we started with. What they ended up doing is showing, do magnets help reduce the pain? So in this case, researchers carried out an experiment using as subjects as 50 volunteers with chronic pain. A completely randomized design was used, with 29 subjects receiving the active magnet treatment and 21 getting a fake magnet treatment. Down here we see the results on if they had the fake treatment or the actual treatment. The average pain rating for the treatment was recorded, and it was 8.43 for the inactive magnet and 4.38 for the active magnet. The difference here we're going to notice is definitely statistically significant. So based on this, what conclusion can we draw? The difference in the average response for the two groups was too large to be explained by chance alone in a random assignment. So we can infer that the magnet treatment caused a reduction in pain because the actual experiment took place. But since the subjects were volunteers, we cannot safely generalize these findings of the experiment to any larger population. The only population we consider are actually the 50 volunteers who were part of the study.